Hi, welcome once again to our YouTube channel. Thanks for subscribing to our channel. It's another time with us here. Today we want to look at another aspect of gas laws, like we have been discussing gas laws. So we want to look at another aspect or another law in gas laws, and that is going to be talking about the Charles law. Today we are talking about gas laws, and the aspect that we'll be looking at is the Charles law. That is the aspect that we want to look at. So what is Charles law? Since we have been talking about gas laws, we'll be looking at the relationship or the properties of gases and the relationship between so many materials, talking about temperature, pressure, volume, and the rest of those. So today we'll be looking at Charles law. So without wasting our time, what is Charles law? Charles law Charles law states that the volume of a given mass of gas is directly proportional to its temperature in Kelvin provided that pressure remains constant. That is what Charles law is talking about. It states that the volume of a given mass of gas is directly proportional to its temperature. A temperature in Kelvin, we can see that temperature in Kelvin, that is very, very important. It is a very, very important point to note. So the temperature must be in Kelvin. So, and that is going to be at what? At constant pressure. Mathematically, what does it mean? Mathematically, what Charles is trying to tell us is that volume is directly proportional to temperature. That is what Charles law is trying to say, that volume is directly proportional to temperature. So if volume is directly proportional to temperature, let us try to see if we can substitute. Let's try to remove this proportionality sign. So removing the proportionality sign, we'll be having it looking like this: volume equal KT. Volume equal KT. So if you try to make K subject of the formula, let me reverse this. So I am having KT equals volume. So if I try to make K subject of the formula, I will be dividing both sides by T. So divide both sides by temperature. So I'll be having KT divided by T equals V over T. So when T takes out T, we'll be having the resultant to be, what we'll be having here is going to look like this. We'll be having it looking like this: K equal V over T. K equal V over T. So eventually what we'll be having, when we look at it, we'll be having it looking like this: V1 over T1, and it could also give us what? V2 over T2. So that is what Charles law is trying to tell us, that at constant volume, or at standard volume, we have the volume of a gas to be directly proportional to its temperature in Kelvin. Please note that we are making mention of that. It is very, very important that we understand why this is. It must be, the unit of that temperature must be in Kelvin at constant pressure. So this is what Charles law is saying. So graphically, this is what Charles law looks like. Graphically, this is what it looks like. We have something like this, that when temperature is increasing, volume When volume is increasing, temperature is also increasing because they are directly proportional. So we have something that looks like this: V1 at T1, we have V2 at T2. We see that as volume is increasing, so also is temperature. At V4 here, temperature has also increased to what? To T4. So basically, this is the origin. So basically, that is what Charles' law is saying graphically. So that is what we are talking about. So what we have here is just what Charles' law is talking about. So before you be able to apply Charles' law to any gas equation, you must be able to make sure that all your parameters are at the normal units of the question. So let us just take a few examples so for us to be able to understand what Charles' law is talking about. For us to be able to understand Charles' law properly, we need to understand the reason why we keep saying that the temperature must be in a particular unit, which is Kelvin. So perhaps you are given, peradventure, let's assume you are given your unit in temperature to be in another scale. Probably you are given it to be in Celsius scale, which oftentimes comes to be. How can you then convert it? I'll just give us a few examples and then we go into answering questions. So let us 0 degrees Celsius to Kelvin, or we have 37 degrees Celsius, or the third one, let's say we have 100 degrees Celsius. How do you convert them to Kelvin? All you need to do is to add 273. Adding 273 to all of them gives us the Kelvin scale. For this one here, 0 plus 273 will give us 273 Kelvin. Now note that we did not put degree in Kelvin. We just wrote the Kelvin there. Unlike in Celsius where we have to put the degree. Looking at this one here, it automatically gives us 310 Kelvin. And this one here, 100 degrees Celsius plus 273 will automatically give us 373 Kelvin. So that is how we convert Celsius scale to Kelvin scale. 1. If 340 centimeter cube of a gas at STP is heated at STP is heated to 37 degrees Celsius at constant pressure. Calculate its new volume. Calculate its new volume. Standard temperature equals 273 Kelvin. And then we have the standard pressure to be 1.01 multiplied by 10 raised to the power 5 Newton per meter square, or we have it to be 760 millimeter mercury, or it can also be seen in form of ATM. So we have it as 1 ATM. So that is what that particular question is looking like. If 340 centimeter cube of a gas at STP is heated to 37 degrees Celsius at constant pressure, calculate its new volume. If standard temperature is this, standard pressure is this, then we should calculate the new volume of that substance. So that is what we want to calculate now. That is what we want to look at now. So what we are saying here is, at this particular volume of the gas at standard temperature and pressure, if the temperature increases to this, or if it is heated to this, what then is going to happen to the volume? That is what that particular question is talking about. So let us quickly solve that, writing out our parameters first. So here now we have our V1 to be 340 centimeter cube and our T1 is standard temperature. We have it to be 273 Kelvin. So our V2 from the question is unknown. We are told to calculate the new volume at T2, and our T2 we said it is at what? 37 degrees Celsius. So first and foremost, we need to convert this from Celsius scales to Kelvin scale. That is how we can solve this question. We cannot use them as they are like this. Kelvin here as T1 and as T2 is in Celsius scale. We cannot use them in opposing units. So we have to bring them to the same unit, which is Kelvin, which is the accepted unit. So we have it to be 37 plus 273. 37 plus 273, and that is going to give 310 Kelvin. 310 Kelvin. So our T2 is now 310. So let us now bring in Charles' law. Charles' law mathematically says that V1 over T1 equal V2 over T2. So making a straight line equation, we have V1 T2 equal V2 T1. And from here now, we're looking for V2. So let us make V2 subject of the formula. So V2 equal V1 T2 over T1, which is the coefficient of V2. If we get to this point here, all we need to do now is to input our parameters. So we have V2 to be equal to, our V1 is 340 multiplied by our T2, which is 310. Our T2 is 310 divided by our T1, which is 273. And that is going to give us our V, giving us 105,400 divided. That is giving us 386.08. To whole number, to significant figure, we have our V2 to be 386 centimeter cube. Since it is a volume, we have it to be in centimeter cube. So that is how that first question is going to be answered. Alright, example 2 now says a gas at 40 degrees Celsius occupies a container of 470 centimeter cube. What will be its temperature? What will be its temperature when its volume? What will be its temperature when its volume become 700 centimeter cube at unchanged pressure? That is the second question that we have there. A gas at 40 degrees Celsius occupies a container of 470 centimeter cube. So what will be the temperature when the volume becomes 700 centimeter cube at unchanged pressure? That means the pressure remains constant. That is signifying that we are still talking about Charles' law. So first and foremost, you need to write down the parameters for you to be able to solve it. So from the question now, a gas at this temperature occupies a container of this. So we have our T1 to be 40 degrees Celsius, and our V1 at this particular temperature is 470 centimeter cube. So we are told to calculate the T2 now. What will be its temperature? So T2 is unknown as V2. Our V2 is 700 centimeter cube. So from here now, we need to bring out our Celsius. Our T1 is in Celsius scale, so we need to convert it to Kelvin scale. So T1 is 40 degrees Celsius plus 273, and that is going to give us 313 Kelvin. That is going to be the unit of that particular temperature. So we have our temperature, which was given as Celsius scale to be 40 degrees, converted to Kelvin, it is now giving us 313. So now we can bring in our Charles' law. So we have V1 over T1 equal V2 over T2. Straight line equation will give us V1 T2 equal V2 T1. And from here now, since we are looking for T2, we can make T2 here subject of the formula. So we are having T2 equal V2 T1 over V1. If you can get to this point here, all we need to do next is to impute our parameters. So we have T2 equals our V2 here, we have it to be 700 multiplied by our T1, which has been calculated to give us or converted to give us 313 divided by our V1, which is 470. That is giving us 100 divided by 470 to give us 466.17. So that will invariably give us 466. Since it is temperature, we can leave it at 466 Kelvin. So that is the unit of this particular question. That is going to be the way this particular question is being calculated. So at this temperature, we have 313 Kelvin increasing to 466 Kelvin because our volume, which was 470, has increased to 700. So that is what Charles' law is talking about. So direct proportionality. Example 3. Calculate the temperature of a gas that would have yielded 500 centimeter cube when its temperature at 350 centimeter cube was 55 degrees Celsius. So we are told to calculate the temperature of a gas that would have yielded 500 centimeter cube when its temperature at 350 centimeter cube was 55 degrees Celsius. This particular question needs you to understand the use of tenses in English language. So looking at this now, this is how we bring out our parameters. Calculate the temperature of a gas that would have yielded. So this would have been our V2. We have our V2 to be 500 centimeter cube. So the temperature at V2 will be T2, and so that is what we are looking for because our V1 is 350 centimeter cube and our T1 is 55 degrees Celsius. So let us convert our Celsius scale in our T1 to Kelvin. So that will give us this 55 plus 273. 55 plus 273, and that will give us 328. So 328 Kelvin. This is going to be our new T1. Now we can bring in our Charles formula, which is V1 over T1 equal V2 over T2. Straight line equation will give us V1 T2 equal V2 T1. And since we are looking for our T2, let's make T2 here subject of the formula. So T2 equal V2 T1 over V1. If you get to this point here, all you need to do is now to impute your parameters. So we have T2 equal our V2. Here's our V2, 500 multiplied by our T1, which is 328 divided by our V1. V1 is 350 centimeter cube. 350. So we're giving us 164,000 divided by 350 to give us 468.57. So when we make it a significant number, we have 469. Since it is temperature, it is going to be in Kelvin. So that is how that question is going to be solved or calculated. So now we understand how Charles' law is being applied to gas laws. I believe with all of these, you now have a better understanding of what Charles' law is. Perhaps you have any question that you want us to help you take a look at or help you solve, please don't forget to put them down in our comment section. If you are yet to subscribe to our channel, please don't fail to do so. Subscribe to our channel and don't forget to click on the notification button, because doing that will help you get easily notified when we put up new content on our channel. Thank you very much for coming along with us. It's a wrap for today. Bye.